Okay boys, I'd like to turn our minds now to the elimination method. Now in this example I've got here, it would be perfectly possible to use the substitution method by rearranging equation 1, making either x or y the subject, it wouldn't matter, and working with it from there. But here's a fairly basic example of the elimination method, and here's the big idea behind it. The big idea is that what you're trying to do is make one of the coefficients of either x or y the same. Here they're not, are they? I mean, the coefficient of x is 1 and the coefficient of x is 2 here, whereas it's 1 and 5 there. So that's the big idea, making the coefficient of either x or y the same in both equations. So we normally do, well, we always do that by multiplying through or dividing through one equation by a scalar, by a number. Okay, so here what I'm going to do is multiply equation 1 through by the number 2. So we'd get 2x plus 2y equals 28. Okay, then I've got the coefficient of my x's the same in both equations. Okay, so here we go. And we tell the reader what's going on as we go. So we say equation 1 times 2. And we get 2x plus 2y equals 28. And I'm going to rebadge that one equation 3. And then I'm going to write down equation 2 like so, equals 55. And what I can do, that's still equation 2, hasn't changed a bit, so it's still 2. What I can do is subtract one equation away from the other. Okay, I put the subtract sign in a circle to indicate I'm not talking about negative 2, I'm talking about subtracting this whole equation from that equation. And you can see what's going to happen, can't you? It's called the elimination method because when I go 2x minus 2x I get nothing, so I've eliminated the x's. And so then I go to 2y, subtract 5y equals negative 3y. And 28 take 55 is negative 27. Okay, so dividing both sides by 3, by negative 3 in fact, I'm going to discover that y is equal to 9. Now you can probably imagine what happens next. I'm going to substitute y equals 9 into the equation of my choice. Equation 1's looking quite good at the moment. So I'm going to say substitute y equals 9 into equation 1. And this one's going to be easy. So we get, therefore, x plus 9 equals 14. Therefore, x equals 5, subtracting 9 from both sides. So I'm going to write my answer as a pair of coordinates as usual. So answer, I'd only do this if my variables were x and y. Oops. 5, comma, and y was 9, wasn't it? So there we go, that's our answer. That's our first example. Here's our second example. Now in contrast to the first example, there's no single number I can multiply both equations through to get a situation where the coefficients of either x or y are the same. So I've got to come up with a different technique, and fortunately it's reasonably straightforward. My approach to this sort of problem is to do the following. Firstly, I look at the equations and I work out which coefficients in general have the lowest numbers. I've got a 3 and a 2 there, which is lower than a 2 and a 5. So this is my approach, and this is the big idea. Again, remember the idea is to get the coefficient, either x or y, coefficients of x or y to be the same. So the trick is, what I can do is multiply this equation through by that number, and multiply this equation through by that number, and you'll see what happens. So, and I'm not interested in the signs. The fact that that this is negative and that is positive doesn't interest me much at all. So what I'm going to do is tell the reader what I'm doing, and so I'm going to multiply equation 1 by 2. And what that gives, of course, is 4x minus 6y equals 10. And I'm going to multiply equation 2 through by 3. Okay, so what I'm going to get there is 15x plus 6y equals negative 48. Okay. Now, I'm going to relabel these equations 3 and 4. Okay, so what I'm going to do now is subtract equation 4 from equation, I'm going to add equation 4 to equation 3. Now why I'm going to add is that if I subtracted, what would happen here? I would get minus 6 minus positive 6y would be negative 12y, and I wouldn't have eliminated the y. So when the signs are different, you add. When the signs are the same, so if that was negative 6y, you would subtract. Okay, that's important to remember. But anyway, I'm adding these equations, so this is what I get. 4x plus 15x is 19x. The y's get eliminated, of course, and 10 plus negative 48 is negative 38. Okay, therefore, dividing both sides by 19, I get x equals negative 2. That's good. I found a value for x. Now all I need to do is find a value for y. And I think you know how to do that by now. So we pick the equation. Any equation will do, of course, but I'm going to pick equation 1 to substitute x equals negative 2. I'm picking equation 1. And here we go. So 2 lots of negative 2 minus 3y equals 5. Tidying up, we get negative 4 minus 3y equals 5. Therefore, negative 3y equals positive 9. And therefore, y equals negative 3. Okay, so writing our answer neatly, we get answer x is negative 2 and y is answer x is negative 2 and y is negative 3. And again, to re-emphasise the point, what we found there is that if we were to graph these equations, equation 1 and 2, or 3 and 4, what we'd have found here is the point of intersection of those two lines.